Hi everyone, my name is Jeremias Gibilbank. I'm part of the architecture team here at Whiteprom. Today, I will be talking about a CDK construct to use or not to use. First of all, let me introduce you what an OTT is. It's a space where we share knowledge with our teammates. So if you want to share anything you find interesting, feel free to reach out with us. Also, we upload them to YouTube, so please subscribe and give us a like. So CDK constructs, to use or not to use, that's the question. Today's agenda will be the following. First, I will introduce you the CDK. Then we will talk about what exactly CDK constructs are, types of constructs that there exist, the construct library, custom contracts, advantages, disadvantages, and finally to use or not to use. Let's first introduce CDK. So CDK enables cloud application development by using programming languages, standard programming languages. So it's a way to define our AWS infrastructure in a seamless way than using directly CloudFormation. But in the end, it integrates with CloudFormation. So they have easy AWS resource setup. This means default settings and less codes. They have lots of default settings for everything using the well-architected framework. The architecture is code-like infrastructure because it uses standard languages. It integrates with CloudFormation, and they have implemented shareable patterns and a way to reuse designs. And that's what exactly constructs are. The languages available for using CDK are TypeScript, JavaScript, Python, Java, C#, .NET, and Go. In fact, CDK is written in TypeScript, but with a tool called GSII. You can use the same tool in any other language available. Here I describe how the CDK app lifecycle is. So this graph here represents the CDK deploy command. And these are the steps that go through the pipe until you get your template deployed. So once you have your source code written, you run CDK deploy, and this will do these 4 steps to produce the templates that later on will be deploying through CloudFormation. This box contains 4 steps. The first step is construct. It's the step that does mostly all the job. They instantiate the classes of CDK and they initiate the classes. So this builds up all the objects of CDK. Then there is a step called prepare. Every construct can use it. Is a step where you can put some defaults and change in some way how the construct behaves. Be careful, because if you change too much how a construct behaves, you might be changing the construct itself. Then there's a third step where validation happens. Most constructs have a validate step where they validate that everything is well built in order to be synthesized in the last step. And the actual last step is synthesize. This is the step that takes all the abstractions that we built in CDK and transforms that into a CloudFormation template. Then the last step is running the CloudFormation deploy. And all these steps are wrapped in the same command. So you just run CDK deploy and you get all this pipe running. So let's talk about CDK constructs, what they are. They are just building blocks for AWS CDK apps. They represent cloud components for AWS CloudFormations. They are a higher level to define those components in comparison to traditional CloudFormation templates. There exist 3 types of constructs. They are organized in levels. The level 1 constructs are the ones that provides CDK. They are the lower level of abstraction. They represent directly one CloudFormation resource, and you can do with them anything you can do with CloudFormation. They have all the same parameters, and they have all the same kind of relations with other resources. Obviously, as they are exact abstractions from the same resources, they require a manual configuration of all the properties. An example that we have here is a CFN bucket for AWS S3 bucket. CFN bucket is the way that CDK calls the level 1 construct for a bucket. And every time you see a construct that begins with CFN, means that it's an abstraction one-to-one with CloudFormation. Then we have the level 2 constructs. They are a higher level API over the AWS resources. The difference between L1 and L2 is that L2 comes with defaults. It's kind of the same main resources, but with defaults. So here we have an example, a S3 bucket with additional methods. This means that if you use a level 2 construct, you will get an S3 bucket with some configuration inbuilt. All the configurations that AWS CDK official constructs comes with are on pair with AWS both good practices and well-architected framework practices. Then we have the L3 constructs, and they could be called patterns. So where they are defined for common AWS tasks, and they incorporate multiple resource types. Something important about them is that they are oriented for you to use them when you need a pattern, a common pattern. For example, let's say you need the standard pattern for ECS with a VPC, with high availability, and you need it to be multi-region. So for example, the service that we are seeing here is a way to define an application that is load balanced with a load balancer and is implemented in Fargate. Just running this ECS pattern creates all the underlying resources for this to work. So this is the AWS Construct Library. It's the official AWS Construct Library. There you will have lots of the 3 levels constructs you can see here. You can see them documented, and they are implemented in all the languages that CDK support. So maybe let's see if I can open it here. Here you will find all the documentation. For example, if you want to see some Python documentation, and let's try to open, I think I have it open here. Here, for example, this is the service that I have been talking about. This is a level 3 construct. It's a pattern, and it's the pattern of the application load balance in a Fargate implementation. Here you can see how you can call this pattern to implement it. And as you can see here, there is a bunch of things that you can configure in relation to this construct. It's not that you can configure everything, but you can configure most use cases that you will need. So here you can see all the parameters that you can configure and you can extend from this pattern. Let's go back to the presentation. And there also exists a way to declare custom constructs. The importance of custom constructs is that you can reuse a component-oriented group of AWS resources to not be re-implementing everything once and again. So developers can create their own constructs. They have the same form as official constructs have. You can extend the construct class, and you can start building a group of components that behave in a way, and you can decide what that construct can receive as a parameter and what they do as an output of that construct. Something that is important is that AWS encourages you to use a composition pattern. So every time you want to build a construct, the correct way will be doing composite between your different constructs. Here you can see this page. This is construct.dev. Here you will find construct patterns for all the CDK libraries. You will see here that there's also one called CDK TF that interacts with Terraform, and one called CDK 8 that is for Kubernetes. Here they are all mixed, but you will find lots of stuff. Something important to know is that community constructs are not implemented in all the languages. They are only implemented in one language, and maybe if the developer did it, it could be in other languages. That's the difference with AWS official constructs that are implemented, as you can see here, in all the or in these 4 languages for CDK. Obviously, also TypeScript. So, sorry, let me show you some. Here we have an example of an ECS construct being used. This is the Python version. We could see it in TypeScript, JavaScript, Java, C# or Go. Let's go through the Python example. So here I'm having what is called a stack. And a stack is part of my application. An application can contain multiple stacks and they can interact together. So in this example stack, I'm instantiating one pattern, is the one that I've been talking about. For instantiating this pattern, I can, if I want, declare my own VPC. If I don't create it, this pattern creates it for me. And I'm doing the same thing for the cluster. If I don't declare the cluster, this construct will declare and create it for me. The advantage of declaring these two resources outside my construct is that I can customize them as much as I want, and I can even add more services to my same cluster apart from this service where I'm using a construct. So here we can see that this creates my target service with this construct. We assign the cluster, we set some CPU stuff, the desired count of the containers. Here they are choosing to use an example image. Here I could use any image that I have uploaded to any registry that this service can access. A memory limit, and it says that it has a public load balancer. This could have been using any of the, have it here, any of these properties that are documented here. So for example, we can assign security groups, assign subnets, and lots of more stuff. The return of using this construct, if I assign it to a variable, will be the actual service. So everything I can do to a service in CDK, I can do it to the return of this function. This is great, and it seems like magic, but something that we have to have in mind is that this code that is like 20 lines produce a template that looks like this. So 500 lines, and it can start getting bigger and bigger. What this means is not that it's just a big template, but it contains lots of resources. So you could see there are lots of resources being used here at CloudFormation that if I am not an expert on CloudFormation, neither on AWS, this could be a mess. So something to have into account when we use either CDK or CDK Constructs is that we should understand what they do on behalf of us. Because if we are using this on production or on an application, if we have any trouble with any of these resources, we won't know what's happening inside. So one option is either not using a construct and doing everything manually, or using the constructs for specific things that we know what's happening in the background. Also, as I can build my own constructs, I would probably be creating constructs, custom constructs for those things that I repeat and repeat in every project I do. So I can extend, and I can even extend that and share between teams, and teams can ask each other to add features, to add settings, or whatever we need. So wrapping it up, let's talk about some advantages and disadvantages. So we have higher level of abstractions. That's really awesome in comparison to CloudFormation that lacks an abstraction for this type of paradigms. It has a programmatic approach. We are using standard programming languages, so we don't need to learn any new language if we are already developers. We have defaults. This reduces manual configuration that we have to repeat and repeat in every project. We have the reusable components. We reduce the boilerplate code. If you look at most CloudFormation templates, you will see there's a lot of code that you have to put every time that doesn't do anything, but it's needed. Also, it provides granular control because as it's mapped one-to-one with CloudFormation, we could change every setting that we can change on CloudFormation, and that means every setting that we can change on AWS. It has better readability as it's code, and you have auto-completion, you have lots of ways to understand it. It's kind of self-explanatory. Then the construct encourage composition. This is important. And you can create libraries. When we talk about libraries and packages, we are also talking about constructs. That's the thing I said about custom constructs and sharing that with other teams. And as they have standards inbuilt, for example, the level 3 constructs have every AWS well-architected framework standard inbuilt, we can trust those components that AWS provides us. And then let's talk about some disadvantages. So the first thing is the learning curve. CDK has a bunch of concepts that I didn't talk here because it was more oriented to constructs. They have a bunch of concepts that we need to understand, and we need to look at the best practices to use it correctly. The language constraints, although you can use a bunch of languages to code it, when you choose one, you cannot use the other. So you need people that use this to know all the same language. This is the thing that I underlined it because it's the biggest disadvantage. And this abstracts a lot of complexity. If we don't know what's happening in the background, that could be a mess when we need to fix something, or even when we need to change something. Then compatibility. CDK is in the version 2, number 2. And when it changed from version 1 to 2, migrating to the version 2 was kind of a mess. So something to have into account. I hope that on next versions, they don't do the same, but it was a pain migrating from one version to the other. It could be less control. In fact, if you use too much the patterns and the constructs, you lose control, or you lose the fine-grained control that plain CloudFormation gives you. So this is more related with level 2 and level 3 constructs. And lastly, the ecosystem maturity. CDK is pretty mature, and it's being used in lots of projects and in lots of companies. But it doesn't have yet a big community like other tools like Terraform, CloudFormation, and Pulumi, and other tools for IAC right now. No, in any case, it's growing, and there are new things every day. So, summing it up, to use or not to use. It depends on your team. It depends on your actual team knowledge. I see as an advantage on using a programming language to declare infrastructure, so you don't need to learn a new thing. The tool is pretty robust. The tool is pretty established. And the only thing that I will be careful is when using higher abstractions and higher abstractions and higher abstractions, be careful of knowing what happens in your behalf. And just to give you one example of that, this construct that we saw creates this number of different resources. So you can see, if you just don't know what these are, then don't use this construct. Because if you have any problem or you have any cost issue because of any of these resources, you won't be able to fix it or neither change it to another type of service. So that's it. Thank you all for coming today. And that's it. Have a nice Friday and have a nice weekend.